prove that the sum of three consecutive integers is divisible by 3. First of all, let's try a specific case. Let's look at a particular case. Let's do 23 plus 24, 25, and show that if we divide that by 3 and we get an integer, i.e. a whole number, then we know these three numbers are divisible by 3. So adding them together, we get 72 divided by 3, and 3 goes into 72 exactly 24 times. Therefore, it's divisible by 3. However, this is just a particular case. We need to show it's true for all cases. So to prove for all cases, we must use some algebra, and we're going to use a direct proof. If we let the first integer be n, or you could let it be x if you want, the next consecutive one, consecutive means the next number, will be n plus 1, and the one after that will be n plus 2. Now if we add those together, so the sum of these numbers, so n plus 1 plus n plus 2, so we've got n plus n plus n, which makes 3n, and then 1 plus 2, which is 3. Now there's a common factor here of 3, so we're factorised. We've got 3 brackets n plus 1. Now it doesn't matter what n plus 1 is, this is a multiple of 3 and therefore is divisible by 3. Okay, so therefore these numbers are divisible by 3. So therefore the sum of 3 consecutive integers is divisible by 3. Okay, so this has been a video to look at the idea of direct proof and using a little bit of algebra. I hope you've understood, and I thank you very much for watching.